Okay, we're just looking at a topic called force, momentum and motion, and we're just going to have a look at some of the basic laws. So the first law we're looking at is Newton's first law. So unless acted on by a resultant force, a body remains at rest or in uniform motion in a straight line. So basically, if there's no force acting on it, either the thing keeps moving at the same pace or it's actually at rest. So what happens is in the effect is if the same force produces twice the acceleration on an object compared to another object, we could say that the mass of the object that accelerates faster must be half. So if a force produces twice the acceleration, it must be half the weight of the first object. Okay, so let's move across, copy that down. Newton's second law, the acceleration of a body is directly proportional to the force and inversely proportional to the mass. And you might have seen this in science before. This force equals ma, change my pen. So force equals ma is Newton's second law. Force and acceleration are both vectors and mass is a scalar. So basically, the acceleration is directly proportional to the force and inversely proportional to the mass. Okay, so copy that and come across. We're looking at some questions soon. So we've got a question here. So we've got a hot air balloon and the vent at the bottom is open so that the balloon starts to come down to Earth. The mass of the balloon is 600, I think that should be mass is 600 kilograms. Okay, just change that to kilograms, not grams. The original height of the balloon is 120 meters. Gravity is the force, and that's exerting a force of 5,880 newtons. That's pushing it down, but there's still some air in the balloon, and that's exerting a force up of 5,000 newtons. And we have a wind from the west exerting a force 300 newtons from the west, so it's heading towards the east. So what's the acceleration of the balloon? How long until the balloon hits the ground? And at what speed does the balloon hit the ground? So we're going to go back to our vector days, and we're going to look at the vectors that are acting on the balloon. The forces. So we've got 5,000 newtons up. The balloon's here. We've got 5,000 800, that should just be 5,800, not okay, sorry about that, that's just 5,800, and then we have a wind acting at 300. Okay, so we have to look at how these vectors are adding together. So this 5,000 is going to cancel out 5,800, and we're going to be left with just an 800 down and a 300 sideways. So we just add the two vectors together, so the resultant vector is going to be this way. Okay, so then we'll put 300 there, and that is going to be an angle we use for trigonometry. So we've got a right angle triangle, so this resultant force here, F will be the square root of 800 squared plus 300 squared. And when you put that in your calculator, you get 929.7 newtons. Tan of the angle is 300 over 800. So when you do that on your calculator, you get 18.8 degrees. Okay, keep going. So now we've got force equals mass times acceleration. And we're trying to find the acceleration, so acceleration equals the force divided by the mass. So this is part A. So the force is 929.7. The mass, hang on a sec. I think the mass was 600. I can't remember what I wrote at the top, but the mass in my example is 600 kilograms. And so when you put that, you end up with 1.55. Now, with acceleration, the unit of acceleration is meters per second squared, or meters per second per second. Okay, part B we're doing now. So we've got just being paused there for a sec. So we've got the acceleration down. We've got the force acting at 1.55, and the angle is 19 degrees, or 18.8 degrees, so I just round that to 19, so I'll make that 19 degrees there. Okay, so then we've got, just change the colours, So we've got cos 19 equals the acceleration vertical divided by the force. So acceleration in the vertical direction is 1.55 times cos 19. And then we've got, using our calculus, the rate of change of velocity is called the acceleration. So v equals the integral of a with respect to time. So that equals 8t plus c. Now the initial conditions when time was naught, the acceleration wasn't acting on it and there was no velocity. So that gives us c equals naught. So then we've got v equals at. Alright, and then we've got the rate of change of displacement is the velocity. So s equals the integral of v dt, which is the integral of at dt, which is half at squared plus a constant. When t equals 0, the displacement was 120, so c is 120. So s equals a half at squared plus 120. Alright, now, so when balloon hits the ground, displacement equals 0. So 0 equals a half times. Now the acceleration was down, so we make that a minus cos 19 times t squared plus 120. So t squared will equal, okay, that's a minus there, so that'll come across to make a plus on that side. So we'll end up with 120 on the top, and then we're dividing by a half times 1.55 cos 19. So t will equal the square root of that number, which is 12.5 seconds. So that's how long it's going to take, and the velocity v equals at, which is minus 1.55 cos 19 times 12.5 equals, so it's going to hit the ground at about negative 19 meters per second. Okay, so that's the first example. Okay, so let's have a look at momentum. Okay, so this is from the definitions. The momentum of a body is defined as the product of its mass and its velocity. Momentum and velocity are both vectors, and m is still a scalar. Okay, so from this formula, if we derive dp, then we can derive mv, and then we can separate the v to be with the dt, leaving the mass behind, and then dv dt is by definition the acceleration. So we've got this dp dt ends up being ma, but we know that ma equals the force. So the rate of change of momentum, dp dt, is actually equal to the force. So copy that down and come across. So this leads to Newton's third law. For every action, there is an equal and opposite reaction. And this is equivalent to saying that the total momentum of a system remains constant, or that in the system momentum is conserved. So copy that and come across. We've got, I think, got one example to go. Okay, so a ball with a mass of 120 grams, which is the same as 0.12 kilograms, hits a wall directly on at 3 meters per second and rebounds at 2 meters per second, so it loses velocity. The collision on the wall took 2 milliseconds. What was the average force exerted